In this video, I'll be giving the proof for why anything raised to 0 always equals to 1. There is just one exception. 0 raised to 0 is not equal to 1. This is undefined. So the only exception is where x is not equal to 0. So let us see why this is equal to 1. The proof that I'll be giving here is a pattern proof. So we just find the first few numbers and we find the underlying pattern between them, and we follow the pattern to raise to 0 to find what the value is. So let us begin. Just to make things less abstract, let me choose a value, okay? So let x be equal to 2. So 2 raised to 1, as we all know, it is equals to 2. 2 squared, that 2 raised to 2 is equals to 4. 2 cubed, 2 raised to 3 is equals to 8. 2 raised to 4 is equals to 16. So these many are enough. So you see that we'll be finding 2 raised to 0 if we find the pattern between these. Now what you see here is, between these two, if you divide 16 by 2, you're getting 8. If you divide 8 by 2, you're getting 4. If you divide 4 by 2, you're getting 2. So now again, if you keep following the pattern, what you get is this 2, so 2 raised to 1 divided by 2 should give you 2 raised to 0. So 2 raised to 1 is 2 and 2 divided by 2 is 1. So therefore you can generalize it as x raised to 0, x raised to 1 will be x, x raised to 2 will be x into x, x raised to 3 will be x multiplied 3 times. So if you want to go back, you divide by x. Again, you divide by x if you want to go back to the previous power. And again you divide by x. So x divided by x will give you 1. Therefore, any number raised to 0 is equals to 1. So for this pattern, why 0 is an exception, why x cannot be equal to 0, why the base cannot be equal to 0 is, we know that 0 raised to 1 is equals to 0 because 0 raised to anything is 0, right? So if you want to find 0 raised to 0, you have to divide this 0 by another 0. So it's 0 divided by 0. We know that 0 cannot be in the denominator for any number because it becomes undefined, or what we say as infinity. You cannot have 5 divided by 0, 6 divided by 0, or anything. So just like you cannot divide these numbers by 0, you cannot also divide 0 by 0, even though it kind of at first seems obvious because there's 0 in the denominator, 0 in the numerator, and you cancel it off and say 1. But this is not how we do it. So the fact is that we cannot actually divide anything by 0, and hence we cannot divide here also by 0 because this becomes equal to infinity. Or in other words, this becomes undefined. So it becomes undefined. That's the reason why we do not have 0 raised to 0. 0 is an exception for the base. For all the other numbers, no matter if it is fraction, whole numbers, decimals, you always get that number raised to 0 as equal to 1. Thank you for watching this video.